Hi, and welcome to Sequences and Series Part 3 or Day 3. Today we are going to talk about arithmetic and geometric series instead of a sequence and their sums. So the objective is to find the sum of the first n terms of an arithmetic or geometric series. These formulas that we're going to be talking about today are actually going to be given to you on the Regents exam, unlike the other two from earlier in the unit. So the words sequence and series are often used interchangeably in everyday conversations. For example, a person may refer to a sequence of events to a series of events. In mathematics, however, a distinction is made between a sequence of numbers and a series of numbers. This distinction between a sequence and a series can best be made by considering some examples. So here, a finite sequence would be 2, 6, 10, and 14. A finite series is 2 plus 6 plus 10 plus 14. Finite means it ends or terminates. It's a definite end. And an infinite sequence would be 1/2, 1/4, 1/8, 1/16, and so on. And an infinite series would be 1/2 plus 1/4 plus 1/8 plus 1/16 plus, and it keeps on going. Infinite means no end, just like infinity. So as you can see, the difference between a sequence and a series. A sequence is a list of numbers in a specific order, and a series is the sum of all those numbers. So the sum of that finite series that we had on the last page, 2 plus 6 plus 10 plus 14, is 32. In courses after A2T, you will learn that the sum of an infinite series, 1/2 plus 1/4 plus 1/8 plus 1/16 plus whatever, is 1. However, not all infinite series have sums. In this section, we will consider only finite series and their sums. So we're just working with series and sequences that have, or series that have definite ends. So if S sub n represents the sum of n terms of a series, then S sub n can be expressed either explicitly or recursively as follows. An explicit definition would be S sub n is equal to t sub 1 plus t sub 2 plus t sub 3 plus all the way up to t sub n. A recursive definition is S sub 0 is equal to 0, and S sub n is equal to S sub n minus 1 plus t sub n. Okay, here we go. The sum of a finite arithmetic series. The sum of the first n terms of an arithmetic series is S sub n equals n times t sub 1 plus t sub n divided by 2. Remember, n is our term, number term. Or terms, I should say in this case. T sub 1 is the first term, and t sub n is the last term. So for example, find the sum of the first 25 terms of the arithmetic series 11 plus 14 plus 17 plus 20 plus so on. To find the first 25 terms, first we need to fulfill all of our spots in our formula. S sub n is what we're looking for. We're looking for S sub 25. N is the number of turns, so in this case, n is 25. T sub 1 is our first term, which is 11. And T sub n, we don't know. So we actually have to look at our series and find the 25th term. So figure out your common difference first off, and my common difference is 3. And then t sub 25 is t sub 1 plus n minus 1 times d. Well, t sub 1 is 11, n is 25, and d is 3. So when we substitute in, we get our t sub n to be equaling 83. So the next step is to use the formula here. S sub 25 is equal to n times t sub 1 plus t sub 25 divided by 2. So I have 25 times 11 plus 83 divided by 2. 11 plus 83 is 94. 25 times 94 is 2,350 divided by 2 is 1,175. Okay, so that is the sum of the first 25 terms of the series. Okay. The sum of a finite geometric series. Okay, for our geometric series, we need to have t sub 1, which is our first term, and r, which is our common ratio. We don't need to have our last term here for this one. Okay, on the bottom left of this page, I would like you to draw a triangle. Okay, moving on with the example. Find the sum of the first 10 terms of the geometric series 2, negative 6, plus 18, minus 54, plus, and it keeps on going. So n is equal to 10, and we have to figure out r. So remember, we do the second term divided by the first term, so negative 6 divided by 2 is negative 3, or I could have done 18 divided by negative 6 and still got negative 3. And when we substitute into our formula, we'll have 2 times 1 minus a negative 3 to the 10th power over 1 minus a negative 3. Well, 1 minus negative 3 is 4. That's easy to do in the denominator. And then 2 times 1 minus anything raised to the even power right here has to be positive because 10 is an even power. So if we have an even power, we have an even number of negative signs. So this would actually be positive. So I can just do minus, because I have that minus sign there, 3 to the 10th. So on my calculator, I would do 3 to the 10th, 1 minus, times 2, divided by 4, and I would get negative 29,524. Okay?